All right, welcome everybody. We are on Unit 7, Functions. So we'll be talking about linear, quadratic, exponential, absolute value functions. All these different types of functions, comparing them, finding their average rates of change, and that's about it. So stay caught up, please, and you should do great. We have our schedule over here. We have 7.6. That's to be determined. We have to kind of see where we're at and everything. So keep that into advisement. But the plan is that we'll take the test on the 18th and 19th. Okay. All right. So we've done this before. I would like you to, if you would, pause and graph these three equations. You're welcome to use your graphing calculator, do second graph and make a table and come up with those points. That's one way you could do it. Another way would be, since it's in vertex form, we can find the vertex really quick. So if you're trying to do this with the least amount of time, the best way to do it would not to use your graphing calculator. All right? But if you were stuck, you could always graph them. All right, so if you need some help to get started, don't pause yet. If you think you know how to do all this, then pause and do these problems. All right, so maybe the first thing we want to do is we want to write down the vertex. Since this is in vertex form, we can come up with our vertex really easy. Just remember when we take it out of the parentheses, since the form is y equals ax minus h squared plus k, when we take the 4 out, it's going to change its sign. So that's our vertex, and let's plot that. So -4, -1, which would be about here. And then we want to find more points by using our growth pattern. Here A is 1, so we'll do 1a, 3a, 5a, which will give us 1, 3, 5. So we'll go over 1, up 1, over 1, up 3, over 1, up 5. And we'll mirror it over to the axis of symmetry. Something like that, okay? Now we can answer the rest of this. So a max or min value, well, it is a minimum, and its value here will be -1. That's the lowest value it goes. If we want to write down our domain and range, something like that is on your homework. Probably review, maybe a test. So all of this stuff, I guess, is all free game. So domain here starts from -infinity to infinity. Another way you could write that down would be inequality notation or all real numbers. Okay, and that applies so far for any of these equations that we've had. Range is all possible y values. I'd like you to write it in inequality notation because on future lessons we will be using that a lot, okay, instead of using interval notation. So here we want to write it using like less than or equal, or greater than or equal. So for this, it's going to be all y values greater than or equal to -1. All right, so it's all y values greater than -1, and it's also going to be part of that -1. Okay? Okay, and we'll talk about the transformations in a moment. So hopefully you were able to do B and C by yourself. So again, we have our vertex as 1, 1. That's right here, and then we use our growth pattern. So here A is -2. So if we do 1 times A, 3 times A, and 5 times A, that's going to give us -2, -6, -10. So -2, -6, and that will get us all the way outside of our graph. Okay, hopefully this is a nice review. Okay, and then last one we have our vertex here is going to be in -4, 5. negative 4 comma 5, which is right here. And then here a is negative 3. And when a is negative 3, we'll end up doing negative 3, negative 9, and negative 15. So over 1, down 3, over 1, down 9, which is right there. Got our 5 points, and we're set to go. These ones are kind of tough. All right, and then we can answer the rest of this. So here we have a maximum value of 1. Domain, again, is all real numbers, and it's the same for this one. The range is going to be all y values less than or equal to 1. So if we look at our graph, we have y values here and below, nothing above that. So all y values less than or equal to 1. And then for the last one, we have a maximum of 5. And the range here is all y values less than or equal to 5. Okay, so now let's talk about transformations. Each of the above equations are in vertex form. Okay, that's nice because those are the most convenient form to be able to graph. All right, and we're going to also use that form to do our transformations. So on the right side or left side, that is what is called the parent graph. Okay, y equals x squared. So it's basically we have this form, our vertex form, but a is 1 and h and k are 0. Okay, so we want to talk about what a, h, and k do for transformations. We've talked about what a does for like graphing, but if we took an equation that's like this, our parent graph, and we wanted to maybe move it, what are those transformations that we use? Okay, so one thing that we could do, I'll see if this works a little bit, and we've talked about this already. I don't know if I want to spend a lot of time on this, but excuse that. So here we have a parabola, okay, and I can move this over so that it is a parent graph. So h and k are 0 and a is 1. So what transformations do we do if we change h? So if we make h be maybe positive 1, what happens to the graph? Well, it moves to the right 1. Okay. If we move it to 2, it moves over 2. Okay. If h is 4, it moves us right 4. If we make h be negative, well, then here it's going to be like a negative 4. Okay. It moves left 4. Right 4, left 4. So h here does left or right. Okay. K makes it go up or it makes it go down. So if k is negative, it makes it go down. If k is positive, it makes it go up. Okay. And then let's talk about what a does. We kind of talked about that as like our growth pattern. But if we talk about transformations, we talk about it a little different. So if a is 1, we have our parent graph. If a is greater than 1, what we call it, it's vertically stretched. So it looks more skinny. It's been stretched. If a is less than 1, it becomes more wide. And this is called vertically compressed. If a is negative, it reflects it over the x-axis. So here as I go positive to negative and back and forth, it just reflects it over the x-axis. Okay? So that is basically the transformations that we cover in this unit. Okay? So here again, maybe we'll recap what we covered. A, if a is negative, okay, or you could say a is less than 0. Okay, if a is negative, it is reflected over the x-axis. Okay, so again, if we were to reflect that over, it would do the exact same graph. It would just be upside down, more or less, so reflected. Okay? If the absolute value of A is greater than 1, so like if A is 5 or if A is 10, it makes it vertically stretched. If the absolute value of A is less than 1, then it is vertically compressed. Okay? And I mean, and vertical is kind of important because it could be stretched horizontal. So let's just stick with vertical. Will be vertical stretched or compressed. So if it gets skinnier, it's being stretched. If A is greater than 1, it's stretched. Or if A is less than 1, it'll be compressed. And again, we put these absolute values saying that if A is, like if the absolute value of 2, well, that is 2. Or if the absolute value of -2, well, that is still 2. So we're really just looking at the number, not so much the sign. The sign has to do with it being reflected. All right? And then we have our H and K, which we pretty much already know what that is because it gives us our vertex, right? So H, oops, messed that up. Transforms left or right. Okay? And this one's tricky because it's x minus h. It's going to be the opposite of maybe what you would think. And we'll do some examples of that. K transforms the parabola up or down. Okay? And that does exactly what it says. If K is negative, it goes down. If K is positive, it goes up. I mean, I guess H does the same thing. It's just that negative kind of makes you think it's the opposite. All right, so let's just do some examples by going back and answering some of these questions. So looking at that equation, we want to do our transformations. All right, I think maybe perhaps the easiest way is just to do bullet points, and I'm good with that. Some teachers like you to do it as like a sentence structure, but I'm okay if you just do bullets. Okay, so the thing what you're going to want to do is you're going to look left to right. Whatever you come up to first, if whether it be the A, H, or K, you're going to do it first. So first off, we want to say what type of equation it is. And this one is a quadratic. Oops, not a G. Quadratic function. Okay. So we first want to say what type of equation it is because we're going to have other types of equations. So far we only have quadratics. And then we're going to go left to right. So the first thing A here is 1. So that's not going to reflect it. It's not going to stretch or compress. So we're not going to write anything about it. Okay. Next thing we come up is our H. So here we have H is going to be the opposite of what you think. So here it's going to be a -4. And that's what moved it 4 to the left. So we'll say something like transformed left 4. And then next we have is our K. Well, it goes down 1. So we'll go and down 1. So we have a quadratic function that is being transformed left to the, or left 4 and down 1. Okay. Here we could do another example. If you want to pause and give those a try, that would be a great idea. So again, maybe rather than writing it down, we can just talk about it to save a little bit of time. Or maybe we'll do one more together. So we have a quadratic again. Quadratic function. Okay. So the next thing that would come up with is this a, and we have the sign, so that means it's going to be reflected over the x-axis. And it's important to say x-axis because it could be reflected over any line. It could be the y-axis, it could be reflected over x equals 2 or anything like that. Okay, next thing we have is our 2. That means it is vertically stretched by a factor of 2. And then we look at our h. Our h is 1 and our k is 1. So we're going to transformed 1 to the right and 1 up, 1 unit up. Okay, there's lots of different ways, and I try and kind of simplify it a little bit so you don't have to spend as much time, but okay, let's just talk about this one. This is going to be a quadratic that is reflected over the x-axis, vertically stretched by a factor of 3 and transformed 4 units to the left and 5 units up. Something like that would be fantastic. So that is transformations. Now we're going to talk about a different type of equation. It's called the absolute value function. So what does an absolute value function do? What does an absolute value sign do? Okay, it makes anything be positive. So anything inside that parenthesis becomes positive. So anything inside the absolute value becomes positive. Okay, so one way we can kind of look at that is by taking the parent graph of a linear equation. Well, that's just y equals x. So if you were to graph y equals x, if you plugged in 0 for x, you'd get y equals 0. If you plug x equals 1, then you'd get y equals 1. If you plug in 2, you get 2. So it gives you this linear equation that has a slope of 1 over 1 and a y-intercept of 0, 0. Okay? Now what would happen if we used that exact same function, but we made it be an absolute value? Okay? That means that any of these negative values that we have over here are going to become positive. Okay? All those will become positive, and we'll end up getting this shape that looks like a V. And that is what an absolute value function looks like. Something like that. Okay, so the parent graph of an absolute value function is a V. Its shape is a V, V-shaped, and its vertex, we can still call it a vertex, as we did with our quadratics. The vertex is at 0, 0, and then it has this slope that is constant. Okay, so let's talk about the transformations for an absolute value function. Nice thing is that it does the exact same thing with just a, well, it's basically the same. So let's just, I'm just going to, oops, go back, sorry. Go back. So what I meant to do is to just copy this. To save a little time. All right, so it does exactly the same. As you look at it, we still see our A, H, and K, and those A, H, and K's tell us the exact same thing. It still reflects it if it's negative. Okay, it can stretch and compress. It's still transformed left or right for the H, and K still does the up and down. Okay, so let's graph one of these and just see how it looks out, because the only thing that's really different is maybe like when we come up with more points. So for an absolute value function, again, our vertex Here, again, this will be the opposite sign as what you think it is, just like it was for the quadratic. So our vertex here will be in -4, comma, -2. -4, -2, so that's right there. Okay, and then we want to find more points. Here we have a is equal to 1. So and when we had quadratics, we would do 1a, 3a, 5a. With absolute value functions, a is your slope. Okay, and it's just the slope for the right side. So the slope here would go up 1 over 1, up 1 over 1, until we come all the way outside of our graph. And one thing that's similar with the quadratic is we have our axis of symmetry. Sorry, I don't know why that was really struggling for me. So we still have this axis of symmetry, and our graph reflects over it. So the other side is going to look like this. Okay, so to graph, we plot our vertex, we use a as our slope for the right side, and then we mirror it over to the opposite side. Okay, so we can do these other ones too, if you would pause and give these a try. So here we have our vertex is 1, comma, -4, so that's right here. Our a value is 1/2. And that's our slope, so we go rise over run, up 1 over 2, and we only use the right side. And again, we have this axis of symmetry, and we mirror it over to the opposite side. Something like that. Okay? Okay. All right, and then here's your last one, something like 2, comma 1, and then we go, our slope here is -3 over 1, so we go down 3 over 1, down 3 over 1 on both sides. Okay, and if we want to answer some of these questions, this has a minimum at -2. Domain is all real numbers, and the range is all y values greater than or equal to -2. Here we wrote down our vertex was 1, comma, -4. It has a minimum of -4. Domain is all real numbers, and the range is all y values greater than or equal to -4. The vertex here is 2, comma 1. Here we have a maximum value of 1. Domain is all real numbers, and the range is all y values less than or equal to 1. All right, and then we can write down the transformations. What we're going to do is we're just going to write it here, just to kind of save some time. So if we want to identify the parent graph and any transformations associated with this equation, that's what we want to do. So first off, you can do bullets if you want. What type of equation is this? Well, this is an absolute value function. Okay, and again, we look at left to right, so the first thing we see is it's positive, so we don't need to say anything about being reflected. You don't need to say it's not reflected. You don't need to write anything. Next, we have our 4. So that means it is vertically stretched by a factor of 4. Vertically. I'm spelling this all over. You could say by a factor of 4. I think that's probably best. Okay, next thing we have would be our h. We don't have an h, so we don't need to talk about it. And then we have our k, so it is transformed 5 units up, or transformed up 5. Okay, here's another example. So this one's a quadratic. Function. Okay, the first thing we come up with is our negative. That means it's going to be reflected over the x-axis. And then we have that, which means it's being compressed, so it's less than 1. Again, we only look at the sign when we're talking about compression or stretching, or sorry, the number, the stretch or compress. Oh, my word, I can't talk. Okay, sorry. So here we have it's being vertically compressed by a factor of 2/3. And then next thing we come up with is our h. So it is transformed 7 units. And it's opposite what you think, so it'll be right. Or right 7, if you want to say it that way. The k, there's no up or down, so we don't need to write anything about it. All right, another thing you maybe wanted to ask, that you may be asked to, is to write the equation from the transformations. If I tell you what the transformations are, can you write the equation? So for example, here we have a quadratic function, so it's going to be, our vertex form. And then we need to plug in all that stuff. So it says it's being reflected over the x-axis, so we'll have y equals negative, vertically compressed by a factor of 1/3. And then it says it's transformed 1 unit up. So that means it doesn't go left or right, so we'll just do like x minus 0, and then it goes up 1. And then maybe want to simplify a bit by just not having that minus 0. Okay, for C, they want us to do an absolute value function. So it's going to be something like this, y equals a absolute value of x minus h, and then plus k. One thing a lot of people forget is, like, absolute value function does not use an exponent. It doesn't have, it's not squared or anything, okay? So here we have an absolute value function that's reflected. So again, we're going to have a negative. It says it's vertically compressed by a factor of 1/3. We'll do our absolute value. It says it's transformed 2 units down. So again, it doesn't go left or right, and it goes down 2. Here's some others. I'll just write these down. If you want to practice, that'd be a good idea. Okay. That should be a 3. Something like that. Okay, so it's being vertically stretched by 4, and then it's moved to the left 3. And again, it's the opposite. If left is going this way, then we use a positive because it's h minus, or x minus h. And then here's an absolute value function that's vertically stretched by a factor of 4, transformed 3 to the left. So that would be x left would be positive 3. So probably should have adjusted that. Those are like the same. All right. Okay. Last thing is being able to write an equation from a graph. So again, all these you're just going to want to find the vertex and find the a value and then graph it. So this one, it's a quadratic. We have a vertex of 1, 3. And the a value, again, you go over 1 down until it hits, that's a -2. So you do something like y equals -2, x minus 1 squared plus 3. We've done that before, so I don't want to spend a whole lot of time on that. Here's another vertex of 3, -2, and it goes over 1 up 2. So we have a is positive 2, so y equals 2. And then we do x minus 3 squared minus 2. Absolute values, that's a little different. I mean, you haven't done this before, but again, it does the same thing. So here we have our vertex. This is 0, -3, and then we go rise over run. So it goes up 3 over 1. So here our slope is 3. So we'll do y equals 3, absolute value of x minus 0, or just x, and then plus k, well that's minus 3. Here's another. Our vertex here is going to be -1, -3. And then our rise is 1 over 2, so that's 1/2. So y is equal to 1/2, absolute value of x plus 1 minus 3. Again, when you plug it in, it's x minus h, so you'll do x minus a -1, and it will give us a positive 1. All right, well, if you have any questions, please let me know. I hope that kind of helps. Again, the quadratic equation in vertex form is basically the same as the absolute value function, and they do the exact same thing. The only thing that's really different is if you graph it. For the quadratics, we use 1a, 3a, 5a, and if it's an absolute value, then we just use the slope for the right side and mirror it to the left. All right, we'll see you guys.